Hey everybody, here is a quick video on recognizing functions from their tables. The idea is that you should be able to find a XY table and analyze it to decide if a function is linear, absolute value, exponential, or quadratic. So we only focus in Algebra 1 in general on these four types of functions. If you're not familiar with linear, exponential, quadratic, and absolute value functions, you should watch one of my earlier videos, like recognizing functions from their graphs. First up are linear functions. We talk a lot about these. Linear functions are those that change consistently. We say they have a constant rate of change. And that rate of change is so important that we have a special name for it. We call it the slope. Recognizing the table of a linear function is pretty easy. For linear functions, you'll be asked to find the slope and tell if the graph is increasing, decreasing, or neither increasing nor decreasing. We use two general formulas. We use rise over run for slope, or perhaps change in y over change in x. Your approach for all these tables is going to be the same. You're going to start by finding the first difference, also known as the change in y. So we can see this change in y. It goes up 21, up 7, up 21, up 35, and up 42. To be clear, I'm saying, how do you get from negative 76 to negative 55? Well, you add 21. How do you get from 8 to 50? Well, you add 42. If you're confused as to how to get those numbers, the easiest way is to do, say, for example, 50 minus 8 to get 42. Now you might look at this and say, well, is that constant? Is this change consistent? You need to compare also the change in the x values. So adding 21 for a change in 3 for the x value is consistent with adding 7 for a change in 1 for the x value. So we take all of the changes in y and we divide by all the changes in x. And if we find that those ratios are all the same, if they all reduce down to the same thing, then this is a linear table. The slope is going to be what they reduce down to. So 21 over 3 reduces down to 7 over 1. 35 over 5 reduces down to 7 over 1. Same for 42 and 6. So the slope of the table is 7. This is an increasing table, which we can tell because the y values are going up from a negative number to 8 to 50. That's increasing. Next up is the absolute value function. Absolute value functions are the closest to being linear. In fact, each half of the function forms a line segment or array. However, when you look at the function, it's not linear because it does curve, or turn, rather, in the center. Absolute value tables are going to look like two lines that happen to be stuck together. So they're going to look like two linear tables glued together. You're going to start your analysis in the same way. You're going to look for the change in y. The y values go down to, down to, down to, but then switch to going up to, up to, up to. If I look at the change in x, I can see that that's consistent. It's always going up by 1. So in essence, my change is down 2 over 1, down 2 over 1, down 2 over 1. That's the decreasing part of the graph. And then it switches to up 2 over 1, up 2 over 1, up 2 over 1. That's the increasing part of the graph. Absolute value graphs have a constant rate of change, which then switch to the opposite rate of change. So this particular one, we can see from the table, decreases at a rate of 2 over 1, and then increases at a rate of 2 over 1. The place where that change occurs, where it switches from negative 2 to positive 2, is our vertex. And we're used to seeing that for some of our other graphs. All right, next up, quadratic functions. Now these graphs, their characteristic shape is called a parabola. But if we don't have the graph to look at, if all we have is the table, we're going to start by analyzing the change in y. We're also going to look and make sure that the change in x is consistent. Now, I see that I'm going down 10, from 10 to 0, then down 6, then down 2, then up 2, then up 6, then up 10. So this graph and this table, it does decrease and then increase, but it's not at a constant rate. So it's not an absolute value. If it was an absolute value, it would be minus 10, minus 10, minus 10, plus 10, plus 10, plus 10. So what are we to do? Well, we're going to find what's called the second difference. We're going to analyze how the change changes. So how are these red numbers changing? From negative 10 to negative 6, we're adding 4. From negative 6 to negative 2, we're adding 4, and so on and so forth. By golly, they're all the same. So the first difference is not always the same, but the second difference is. That's how we know we have a quadratic function. Quadratic functions have a constant second difference. All right, last up is the exponential function. Now, exponential functions change slowly at first and then quickly. That's easier to see on a graph than it is on a table sometimes. So when we look at a table, we're going to, again, find those changes. We can see that from 0.5 to 1, we're adding 0.5. From 1 to 2, we're adding 1. From 2 to 4, we're adding 2. Now, if I look at that change, what I'm going to notice is that that change number, those red numbers there, those are multiplying by 2. That's how you know you have an exponential table. When the change multiplies by some number, it's called the factor, or maybe it divides by some number, so maybe it's dividing by 3 every time. That's how you know you have an exponential table. All right, now in order to really try and make this stick, here's a little bit of review asking you to compare the following graphs using the following language. The language is increasing, decreasing, and rate of change. So list one similarity and one difference between graphs A and B. So we'll get C out of there for a second. A similarity is that at some point A and B are both increasing. A is increasing all of the time, and B is increasing from its vertex upwards. But a difference is that B decreases on the way down to its vertex, while A never decreases. We can also say that a difference between them is that A has a constant rate of change, while B does not have a constant rate of change. That's synonymous with saying A is linear and B is nonlinear. All right, next challenge. One similarity and one difference between graphs A and C. Well, the immediate similarity is obvious. They're both straight lines, so they're both linear, so they both have a constant rate of change. However, graph A is increasing, while graph C is decreasing. All right, I hope that was helpful. Enjoy your exam.